So here we have our data imported onto our Excel spreadsheet. The first thing we need to do is, you see we have it in these sort of exponential forms. We need to first turn that into just regular numbers. So how we do that is we go ahead and highlight our data. We're going to right click. We're going to click Format Cells. I'm going to go to Number. And then right here, it just has a regular number. We hit OK. That's going to turn all of our numbers into just regular old numbers. The other thing we need to do is, since the tracker program was reading this as negative and we know that is not true, we are looking for the positive values. This situation is going to vary depending on the angle you use and the method of the protractor you use. But for mine, it's all negative and it's all reading from the same side. Sometimes tracker will jump side to side, and you may need to just analyze that on a case-by-case basis. If you need assistance, please send me an email. We can set up a time to review your data and see what's going on. But for my situation, I just need everything to be positive. So I'm going to take the absolute value. I'm going to do equal APS, parenthesis. I can go ahead and click on cell right here. Close that parenthesis, hit enter. That gives me the absolute value of this cell right here. Now I could extend that all the way down to all my data just by clicking in this corner right here and pulling all the way down to my last digit. Next thing we need to do is graph this data. You could have individual graphs for each joint, or you could have them all in the same graph. For this one, I will just put it on one. If you want to do multiple, that is up to you. So I'm going to go ahead and highlight our time because it's going to be our x-axis. Then I'm going to hit Control, and then that allows me to highlight another set of data. I'm going to go ahead and go to Insert, go to these scatter plots, and I will go ahead and choose this one with these smooth lines. I feel this one is optimal in showing the deflection. And after you do this, make sure you add the axis titles and properly label our axes, as well as give the chart an accurate title. So at this point, we should have graphed our angular positions, and we'll move on to assigning the onset, the lowest, and the takeoff points of our subject on this graph. So how we do this is you follow the example on the lab, and we go ahead and insert a line. And how you find these points is you identify them in the video is the easiest way to do it. So the onset is right when the subject starts to move their shoulder. So my onset would probably be right around here at 0.2 seconds. The lowest point is just the lowest point of the subject's movement with their hips coming towards the ground. So mine will probably be somewhere around 0.85, around here. And the final one is going to be the takeoff, and that is where the subject takes off. It's the moment they leave the ground, or the frame where their toes are still on the ground. So I'll insert a shape, and I'll use a line, and I'll do takeoff. So go ahead and draw a line right here, because this is my moment of takeoff, right here at 0.2 seconds, or 1.2 seconds. And we see that line's not very visible. So what we could do is go to Shape Outline, go to Weight, and we could increase the point of that line, do a little bit more, make it black. There we go. And there is our line. Then we could then insert a text box if needed to label it. Because we do need everything to be labeled. This will be our takeoff. Next thing we need to do is figure out how to create the angular velocity graph. This is where things get a little bit complicated. So as we know, angular velocity is going to be the displacement divided by the time. So in this aspect, we're talking about angular displacement. So what we do is we need to create a formula in Excel to describe the angular change and the change in time of these two columns. So since we're talking in changes of angles, we do want them all to be positive. So the first thing we're going to do is going to hit equals, parenthesis, ABS or absolute value, and another parenthesis. And right now we're talking about our angle. So we want to have our final minus our initial. Then we'll close that up. And that's the top half of our velocity equation. This is our displacement right here. So the bottom half is you want to divide it by the time. So we go ahead and do divide by, and then we'll have 0.03 or H6 minus, oops. Make sure you put in parentheses as well. If you don't do parentheses, it will affect your data. So H6 minus H5, so we have our final time minus our initial time. We have our final angle minus our initial angle, and we're taking the absolute value of that. So when I hit this enter key, it gives me a little correction. I forgot a parenthesis right on the end, and it gives us our change in angular velocity. Next thing we can do is pull that all the way down. And this gives us our angular velocity that we could then graph over time. So you want to do this for all joints, and same for the angular positions. You want to do it for all joints. You could have 6 graphs or you could have 2 graphs, just as long as your graphs follow the example of what's given on the lab sheet itself. So I'll quickly graph these. So I'll highlight this data. Hit insert, go to recommended charts. Go ahead and scatter with smooth lines. And you see our data, we have it in seconds instead of our kind of fractions of a seconds here. So what you could do to fix that is you click on the line itself, you right click it, you can go to select data, and we go ahead and edit series 1, which is our data right here, and then we can establish an X value. If we pull there and pull down here, and that gives us our proper X values. After that, you do need to put on proper axis as well as a proper title. Be sure to describe exactly what's going on. And you also need to do a description of the preparation phase and the propulsive phase, as well as the onset, the lowest, and the takeoff.